Good afternoon. We use flow meter as our sensor study in measurement and instrumentation subject. Okay, now I will brief you about the introductions about the flow meter. A flow meter is an instrument used to measure linear, non-linear, mass, or volumetric flow rate of a liquid or a gas. Flow meters range widely in their level of sophistication, size, cost, accuracy, versatility, capacity, pressure drops, and the operating principle. There are two common categories of flow meters, how it functions. There are several types of flow meters such as pitot and pitot probes, obstruction flow meters, positive displacement flow meters, turbine flow meters, pedal wheel flow meters, rotate meters, ultrasonic flow meters, doublet effect ultrasonic flow meters, electromagnetic flow meters, vortex flow meters, and others. As I said just now, we use flow meters as our study. Positive displacement flow meter is one of the water flow meters commonly used in residential and commercial application. Positive displacement flow meters have two rotating impellers driven by the flowing fluid. Each impeller has 3 gear loops, and a power signal is generated each time a loop passes by a non-intrusive sensor. They operate by trapping a certain amount of incoming fluid, displaying it to the discharge side of the meter, and counting the number of such discharge-recharge cycles to determine the total amount of fluid displaced. There are many types of flow meters besides water flow meters to measure the flow of the fluid. Magnetic flow meter is one of them. Magnetic flow meter uses Faraday's law of electromagnetic induction to determine the flow of a liquid in a pipe. In a magnetic flow meter, a magnetic field is generated and channeled into the liquid flowing through the pipe. Following the Faraday's law, flow of the conductive liquid through the magnetic field will cause a voltage signal to be sensed by an electronic located on the flow tube walls. When the fluid moves faster, more voltage is generated. Faraday's law states that the voltage generated is proportional to the movement of the flowing liquid. The electronic transmitter processes the voltage signal to determine the liquid flow. This flow meter does not obstruct flow, so it can be applied to a clean, sanitary, dirty, corrosive, and abrasive liquids. For the part A of the studies, describe how the sensor converts the engineering quantity into the electrical signal. The flow meter's reading will be transferred through analog to digital. However, the reading is in the voltage form, so the voltage form will be converted and calculated into the signal forms later.
Do you know that there are many types of flow meter in the industry? The most common flow meter that we can see is turbine flow meter, which is in our field lab. But there are another flow meter that are widely used in the industry, that is electromagnetic flow meter. So I will explain a little bit about the electromagnetic flow meter. First, I would like to explain about the features. As you can see, it is a microcontroller based with programming capabilities. Another one, it is a high temperature. Third one, it is a corrosive application made of the monel, titanium, and platinum. This is for the electrode. The most important features for electromagnetic flow meter is it is low flow cut-off, amplified detection, adjustable damping, and digital output. Next, I will go through for the advantage. It is a simple structure. It has no moving part, no obstruction of fluid flow throttle parts. Okay, the second one is established wide measuring range. The range ratio is 1/100. It is also can measure average velocity. It has no mechanical inertia, response, and can measure the instant pulse flow. It also has a good linearity, where the signal set can be measured directly, convert the linear converter into a standard signal output. Okay, next I will go through for the disadvantage of electromagnetic flow meter. The electromagnetic flow meter cannot be used to measure the electrical conductivity. It also cannot measure high temperature and high pressure fluid because of the temperature, pipe, insulation, landing material constraints. The third one is it is affected by velocity distribution and traffic signals. It is proportional to the average velocity. The last one is it must have a certain length of straight pipe before and after the flow meter. So that's it for the electromagnetic flow meter.
Further share on the turbine flow meter, as these are the one that we use in our field lab and will be next demonstrated on how it functions. Okay, so why we choose turbine flow meter? That is, well, for all the user of production facilities, there is a significant cost saving involved with the accurate performance of the custody transfers, and the accuracy is typically given in the percentage of actual readings, and the linearity tolerance band of plus minus 0.2% over 0 plus minus over a ratio of 10 to 1 flow range, and plus minus 0.1% linearity in a ratio of 6 to 1 range, and the repeatability is from plus minus 0.2% to 0.02% over linear range. And the turbine flow meter also shows that disadvantage, there is less accurate than another flow meters. There is electromagnetic displacement and also jet meters as low flow rates. And however, the advantage will cover all these, such as this high turndowns, less maintenance due to fewer mechanical parts, and can be used as a duty meter if necessary in times of peak productions or during maintenance of duty meters, and it also gives a better pulse stability during operation. And of course, the most important is lower the cost. Okay, as mentioned above, there's a significant advantage by using these as the master meter. So I think the best selection of this turbine is the most reasonable and best solutions, especially to be used in our field labs. Okay, when using turbine flow meter in these labs conducted, the unit reduce the overall size requirement, reduce overall maintenance of the metering skid, and provides an easy way for user to verify metering skid accuracy. And also, due to relatively compact design of the helical turbine units, a spare master meter can be stored on site to offer complete system redundancy. So it is also cheaper and less demanding, and I would say that this is the best for the simple application like our experiment conducted.
Now, I would like to introduce the application of the sensor in the experiment conducted in fluid mechanics lab, which is current turbine. In this experiment, we have three sensors, which is flow meter, tachometer, and strain gauge. Flow meter is to measure the volume flow rate of water. Tachometer is to determine the rotational of current turbine. Strain gauge is to measure the strain of current turbine. So I will start the experiment. As you can see, it's properly set up already. So we will switch on the machine. In this experiment, we just will focus on only one sensor, which is the flow meter. Flow meter will transfer the reading to analog. And then we will transfer the data into the measurement and automation explorer. Now we run the software. Run it. We will run and we will get the data which is in graph, and then we will get the voltage. Since we will get the data in voltage, so we need to do the calculation to get the volume flow rate. I would like to do the calculation of volume flow rate manually. First, I will use the stopper to block the water flow. When the water is reached 5 liters, we will start the stopwatch. When the volume flows until 10 liters, I will stop the stopwatch. After we repeat the experiment few times, we will start to do the calculation in Excel. This is the value that we get. Is then transferred to the graph and get the equation. Now we will do the transfer the data to Daisyland. We read it in YT chart. Because we get the reading in voltage, so we need to convert the frequency by using power analysis. And then we read in digital meter. The calculation equation that we get in the Excel is now transferred to the scaling, and then we key in the equation that we get before in the Excel, and finally we read it in digital meter. End of our Pelton turbine experiment by using flow meter sensor.
Now I would like to explain the last questions, which is the applications of sensor in industry. There got multiple applications of turbine flow meters in the various industry market. For example, we have aerospace engine testing, gas transmission auxiliary, and also the diesel fuel applications in diamond mines. So, I would like to briefly explain few applications of turbine flow meters in the industry. First of it is the drag racing. The turbine flow meters with a magnetic pickup coil is supplied to meter a nitro-mating fuel mixtures on the supply side of the engine. Hence, in these applications, the turbine flow meters can help the driver accurately monitor assumptions during the race, and this also allowed the car crew teams to evaluate the volume of fuels using during the heat. Next is the applications of aerospace engine testing. In these applications, turbine flow meters has been used to test the large propulsion engines, and it has been playing a key supporter role during the earlier 1960s. Besides that, turbine flow meter is also helped to test the shuttle main engines, which the shuttle is operate at a greater temperature extreme than other mechanical systems. The last but not least is the beverage industry. Turbine flow meters play a key role in production plants through the beverage industry. Sanitary turbine flow meters, along with a batch of the controller, are used to batch a specific amount of the beverage product into a container. The typical filling process incorporates a convenience system and also a filling system. This is end of the part of the applications of sensor in industry. As a conclusion, turbine flow meters is a very simple mechanical sensor. The main function of turbine flow meter is to measure the volume flow rate of a system. With the help of the National Instrument and Measurement Explorer, we can easily to get the data and also a graph. Hence, it has been applied into the field lab in our university. From the previous video show, we can know that The turbine flow meters have been used in the field lab in the experiment of Pelton turbine. Besides that, it also can be used in the field lab with another experiment, which is the pump system. We also, just now, I also mentioned about the applications of the sensors in the industry. For example, the aerospace engine testing, beverage industry, diesel fuel applications in diamond mines, and so on. Turbine flow meters is a very simple, but it plays a very meaningful role and an important role in the applications and also the experiment in our lab and also the industry. Thank you. This is the end of our presentations. Hope you enjoy.